So the big picture for this lesson is composition of functions. When you have composition of functions, f inverse of f of x equals x and f of f inverse of x equals x. So basically you're undoing the original function, gets you the original input. When you're working with trig functions, you just need to be careful about the domains and the ranges. So if the x value is between -1 and 1, and the y value is between -π/2 and π/2, then you can say sine of arc sine of x equals x and arc sine of y equals y. If you have x is between -1 and 1 and y is between 0 and pi, then you can do cosine of arc cosine of x equals x and arc cosine of cosine y equals y. And then for tangent, if x is a real number and y is between -π/2 and π/2, then tangent of arc tangent of x equals x and arc tangent of y equals y. So you really need to be careful about the domain and range, and these connect to the inverse functions that you studied in the last lesson. So here are some examples. Arc sine of π/4 is arc sine of square root of 2/2, which is π/4. So in this case you get π/4 equals π/4 because the π/4 is valid. Tangent of inverse tangent of negative square root of 3 is the same thing as a tangent of -π/3, which is negative square root of 3. F of f inverse of x equals x. And again, that inverse function rule works. Negative square root of 3 equals negative square root of 3. There's a problem with this one though. Arc cosine of 5π/2. 5π/2 is not in the appropriate interval. So what happens is cosine of 5π/2 equals 0. But when you do arc cosine of 0, you get π/2, and those are not equal. And the problem is 5π/2 is not in the interval 0 to pi, so that isn't valid in this case. So the point is, when you're doing these compositions of functions, you can't automatically just put the original number you're starting with for the input. You have to figure out if that actually works, and if it does work, great, but if the input's not in the appropriate interval, it isn't going to work, and so you just need to be careful and think through that. So that's the big picture for this lesson.